Test Thursday and Friday. Thursday will be with a calculator because I'll be here. So if you have a question and how to enter something. Huh? No. Oh, because of musical?
We have rehearsals till 8.
You can do it.
Till 9.
Oh yeah, we have shows till 9.
We're gonna be so dead.
Yeah, sure. Maybe. Hang on. Let me write going. Okay, top, put Fremont Sums.
The test is Thursday and Friday.
And I'm recording it, so you can watch it if you miss something. Okay, so as I was going to tell you, I am not going to be here on Friday, and I know that that is going to stress some of y'all out because during tests, some of you I know like to show me your paper and see if it's right. What?
So we can take it
under the door, yes, I did.
Please take it like.
Okay, no. Okay, you may not. But the reason why is because Ashton, you know, my little 9-year-old, his appointment on Friday didn't go very well, and he has a tumor in his hand. And so I feel like throwing up, but it's okay. So he has a biopsy on Friday. So I might miss y'all's class more based on how that goes. But you're not going to get behind. We're going to do great, okay? So Thursday, you will have your first day. If you have any questions, I'll be here after school today. After school on Thursday. I can't stay tomorrow because it's early release and they have us in meetings. Okay, so if you need help on anything today after school, Thursday after school, you can come in during lunch. But just know on Friday, you will be with the sub. It'll be strict, no cell phones. So emotionally prepare yourself for that. I know usually I don't care if you have an earbud in, but that day, no. Okay? Great. Okay, so integral a to b f of x dx is the exact area between f of x and the x-axis. Okay, now I do want to put one extra little word in here that I forgot. Exact directional area. What do I mean by directional? That if it's above, it'll count as a positive, below will count as a negative, yeah? Okay, so a Riemann sum, okay, Riemann sum is a method of estimating area. Okay, you will usually use Riemann sums on tables where you actually don't have a graph. But remember, if it was a graph of like circles, semicircles, that kind of stuff, rectangles, trapezoids, you would just find the real area. Yes, ma'am?
Why do we fold the paper from
You know what? That's a great question. On the other side, we're going to stay in the boxes. On this side, we're not, though. Great question, though. Okay, so the integral from a to b of f of x dx is approximated by, and then remember, there are two versions. Okay, the first version would be delta x times y1 plus delta x times y2 plus delta x times y3 plus dot dot dot. Okay, now you would only need to use that version if all of your subintervals are different widths. Now you can use that version no matter what. But if they are equal subintervals, what are you allowed to do if all your delta x's are the same? Short version by doing what? If all these are the same, then I can GCF it out. Yes, perfect. Okay, so I'm going to put or delta x in the front, y1 plus y2 plus y3 plus dot dot dot. Now, is this the one where we double stuff? No. No. Okay, that's trapezoidal rule, which we'll get to in a second. Okay, and then I'm going to put a little star here, and I'm going to put only for equal subintervals. Okay? Okay, then at the bottom of that top half of your paper, we're going to put, you have 3 types. What are the 3 types?
Left, right, and
Left, right, and midpoint. Okay, yeah, I'm going to count that as like its own thing. But yes, you're right. Okay, so you have left, you have right. Oh no, I spelled right. Not right. Okay, and then midpoint. Okay, for a left Riemann sum, which endpoint gets skipped? The end. Very good. So I'm going to put skip last y value. What about if it's a right Riemann sum? You're thinking about over and under estimates. This is just more the pattern. You draw it every time, so I don't think you really look at this. Okay, then for a right, you skip the first y value. And then for a midpoint, remember, you don't skip any of them, but you have to make your delta x wide enough to leave a point in the middle. Okay, so I'm going to put for this, you need to skip an ordered pair for each sub-interval. Okay? Now, we are going to do a very tiny little example of how to tell if these are over or under. Okay, but Sean brought up a good point that it matters whether your function's going up or down. So we're going to do an example where the graph is increasing. Okay, but if it's decreasing, then this picture would no longer be accurate. Okay, so draw a graph going uphill. And then I just want you to split it up into 3 pieces. Okay, we're just going to do 3 to keep the picture easy. So 1, 2, 3. This one I'm going to do 1, 2, 3. And then when I draw my rectangles, I'm going to do a left on one, I'm going to do a right on the other. Okay, so for my left end point, okay, I'm using the left side cut across, left side cut across, left side cut across. How does my rectangle compare to my actual area? Over or under the actual value? Under. Okay, now on this one I'm going to do a right Riemann sum. So out of these 2, I'd pick this one, cut across. This one, cut across. This one, cut across. Okay, on that one, is it over or under? Okay, over. So I'm going to put this as an over estimate. And this is an under. If you would like in your free time to draw the opposite version of that, go for it. Okay, but I'm not going to put it on there because you shouldn't really need that. Okay? All right, the other type of sum is a trapezoidal sum. Your integral from a to b of f of x dx is approximated by, and then we're going to do 2 versions, a long version and a short version. For the long version, it's 1/2 y1 plus y2 times the delta x between them, plus 1/2 y2 plus y3, and then the delta x between them, plus 1/2 y3 plus y4, delta x between them, and then 1/2, oh wait, I'll wait and do my dot 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 at the end. Okay, y4 plus y5, delta x, dot dot dot. Okay, now remember, you would have to use that version if all your delta x's are different. Now, some of you like to take the 1/2 out to the front, that's fine. Okay, but you'd have to keep each set of bases multiplied by their unique width. Okay, then I'm going to put or 1/2 delta x. Remember, I can pull those pieces out if all of them have the same width. And then I'm going to add up each of my y values. And then remember, the middle ones get doubled. Hey, let me call you back. I'm in class. Okay, bye. Sorry, it's about like surgery stuff. Or I would ignore it. Okay, y1 plus, and then notice how many times is y2 in there. 1 says a base 2, 1 says a base 1. y3 is 1 says a base 2, 1 says a base 1. So each of my middle terms are going to get doubled. Okay, but remember that the first one and the last one, those do not get doubled. Okay? And then I'm going to put a little star down here and put this is for equal subintervals. Okay? For equal subintervals. Now, how do you know if a trapezoidal rule is over or under? It's not increasing or decreasing. Concavity, you remember? Okay, so I want you to draw a graph that's concave up, draw a graph that's concave down. Okay, so on this side, I'm going to do concave up. On this side, I'm going to do concave down. Okay? Oh crap, that's not concave down. Wow, bad job. You're right, you're so right. Okay, pretend that the other one is not there. Okay, so for my first one, I'm going to splice it up into my 3 parts. And I'm going to slice this one up into 3 parts. And then I'm going to connect my trapezoids and see if they're too big or too small. Okay, so if I connect these 2 endpoints, these 2 endpoints, these 2 endpoints. Okay, are they too big or too small? For the concave up graph. A little bit too big. This is over. Okay, and then if I look at my concave down graph and I connect, I can see that it's just barely, I'm kind of exaggerating on my picture, but it's just a little bit too small. So that would be an under. Okay? So remember that for increasing and decreasing, that tells you for Riemann sums, but for trapezoids you have to check the concavity. Okay? Yes? I messed up. Thank you. Yes? Perfect. You can bring it up here if you think you'll forget, or just wait. Okay, turn over to the other side. Got it? Good? No? Okay. I'll send it out later. Sean.
You got a new iPhone, let's try to take a picture.
You did? What version?
XR.
I just got a new iPhone 7, so don't be jealous or try to steal my phone, guys. Pretty new. Okay, good? Okay. Alright. Other side. Okay, we are going to talk about antiderivatives on this side. So remember that your integral is your exact area. Okay, remember that an integral is an antiderivative. Those are the same thing. Okay, now a lot of you guys are doing some weird stuff on your quiz, and I'm going to pass it back to you tomorrow. I didn't finish grading, but when you do the antiderivative, don't still put the integral symbol. After you do it, it should go away, okay? So, the integral of little f of x dx is called capital F of x plus c. Oh, you know, on the bottom too we will, but no. Okay, and then remember that this is the constant of integration. And remember that if you don't know what the constant is, it's called the general solution. What is it called when you find it? A, good. Okay, to find particular solution, you need an ordered pair to find the value of c. Okay? So a general solution refers to when you don't know the c. A particular solution refers to when you do know the c. Okay? Remember that the integral from little a to b of f of x is capital F of b minus capital F of a, and that gives the exact area. Okay, do y'all remember what that's called? It was really fun. Fundamental theorem, remember? Okay. You don't have to really know the name, but it is called the fundamental theorem. Okay? All right, then the last little bit that we're going to write, if you integrate a to a, what do you get? Okay, good. It is 0. Because think about, if I'm starting and stopping at the same number, I'm not going to generate any area between those. Okay? Let's say that I integrate from b to a. What would I have to do to my integral? If it's backwards. Yep. You would do negative integral a to b. Okay? And so I'm going to write under that backwards. Okay? So remember that your smaller point should be on the bottom, your bigger point should be on the top. Okay, then last one, if you have the integral from a to c, remember that you are always allowed to break that up, a to b, and then b to c. Okay? Okay, then a couple of, yes. Is that good? Okay, Yoel, didn't you make a promise to me today? Of your own volition? Okay, but he's talking to you instead. So. What? Okay. Okay, can I go up a little bit? Okay, then when you integrate from a to b of velocity, what does that give you? Huh? Okay, it does give you position. It gives you the change in position. What's that called? Displacement. Perfect. Now, what if I put bars around it? Distance traveled. Okay, so remember that this is the displacement. Okay, now if you prefer, you can put change in position. That's fine. Over a to b. And then if it's the integral of the absolute value from a to b, that's distance traveled over a to b. And then I'm going to put a little star here, and I'm going to put units. Okay, keep in mind that when you're doing your interprets, if it asks you to interpret on your test, you would want to make sure that you mention whatever your units are. Okay? The last thing that is going to go on your study sheet is not average rate of change, but average value. Remember, there's now 2 averages. And I guess we'll just put both of them on there so you see them next to each other. How do I find average rate of change? F of b minus f of a over b minus a. Now remember, for a derivative, or I'm sorry, for the units, you're doing like a derivative. So if it's meters per second, it turns to meters per second squared. Okay, if you are doing the average value, what is that formula? Or average y value. This was the day, Sean, you laid on the floor and said, this is too easy. Yes, Olivia?
B minus
A, 1 over b minus a. No, I was just trying to jolt your memory. Okay? So 1 over b minus a, integral a to b. And then remember, for that one, since it's the average, I'm going to put here average y value. Remember that your units are the same. So if it's acceleration, this is average acceleration. If this is velocity, this is average velocity. Okay? So I'll put that on here too. Okay, same units as f of x. Okay? we have the remaining 30 minutes, okay, to look through your review. It's kind of long, but you got 2 days. So I'm going to give you 2 minutes, okay, to look through the first page, front and back. That page is going to take you longer than probably all the rest of the review because you're actually working out integrals. Okay, so look through the first page, front and back, and let's pick a few to kind of get you started on. Okay, but I'll give you a few minutes to look through it. So circle ones that you think look hard. Okay? You can look through it together, see if you know how to do them, and if you don't, then we'll do it together.
That was uncalled for.
First of all, don't put it over. Since you only really like shout out.
So, where's my hair?
What do you do with his hair? Okay, so is that what we should be?
And you gave use this content.
Football.
It is increased.
What do you do?
I don't know, I just want him to be involved.
Why do you want to
This girl thinks I look.
You
This girl
basically.
thinks I look like.
I'm not gonna be here.
This girl thinks I look like.
I'm ready.
I'm not gonna be here next week.
Everyone
I
was talking about
have to go to.
So
I do not look like
Like a less club.
So where are your MDs, bro?
Do you have a sense of your
I wore last year, bro.
Where are they?
I wore them like literally every day last year. I still have them.
Not for AP stats?
Where's your Adidas rotate?
I'm gonna throw them in
I bet
the
he
washing
probably
machine.
won't. I would ask him.
Dude, get some Ultra Boost.
Plus, he'll probably be mad at me if I tried to.
Dude, they're
Alright, what period are you reading?
I mean, you can come take your test
Up
anyway.
2.0,
It doesn't matter. It's what period you're free. But he's just not going to get us
Like,
stats to take it.
I
Like
do
a math test.
Yeah, I think I saw them.
And then if you need help,
Pretty sure they don't go for
so you can ask somebody
I just
else.
checked on
Oh,
stuff.
that's.
You want to stay there and help you.
There's 3.04 years.
Okay, what do you think?
I'm funny. Yeah, I'll probably get it.
How do you want those shoes everywhere?
Okay, Brendan, we're not going to talk about the shoes.
What? It's Marcel.
When we, is it Marcel?
Oh no, I wasn't talking about shoes. I was actually asking about number 13.
No, you weren't. You talking about shoes.
Yeah, right there.
Because I wear a size 13, you know, so it was like.
Yeah, go ahead.
Actually, I don't wear a size 13.
That was it.
But number 13 is kind of suspect.
We have to turn in.
Yeah, it's a good movie. And it won't be due till Friday. Actually, I don't want the sub to take it off, so I'll give you till Monday. But if you wait to do the review till the weekend, you're going to mess up your test.
Because it won't help you.
Because it won't thank you. I don't want to train for the marathon after the marathon, right?
This is on Monday because you won't be here on Friday.
Nope.
Yeah, why can't
No
What's not a really
chance.
important question.
Then you can come to tutorials because I'll be here
Because I will be so tired. You don't understand it.
all the time. Oh, I do. I understand. I was in the musical when I was in high school. We did The Wizard of Oz. I played the oboe. I had a few solos. Yes.
You actually played the
And I learned how to play, what's the big one called? Not the bassoon.
tuba?
No, it's like a big oboe, but it's in the middle.
Oh.
I'm trying to, English horn.
English horn.
I had to learn the English horn for the General Winky March, where it's like, oh, wee, oh. And I had to buy like a whole new reed for it. That's pretty band dork of me, but. Anyway, okay, how we doing? What do we think?
Number
Number one or just one in general?
number 13.
The answer to that question is yes.
Okay, let's look at number 1.
Can you rewrite it as my
You do have to rewrite it. Now, let's make sure your rewrite is correct. I'm going to do it on a sticky note.
Doing this in gym.
bring it up tonight?
Yes, okay, tell me if this is right or wrong for number 1. Okay, look, Marcel, you tell us. Is this a good rewrite for number 1? Integral 8x to the minus 3 minus 2x to the minus 2. Tell us, Marcel, is that gonna work? Keep in mind it's not on my paper
Okay,
because
well,
I didn't want it on my paper.
The part, it is right because,
It's incorrect.
wait, mine
It is incorrect. What's wrong with it?
Wait, no, don't tell me,
Don't tell myself.
Don't tell me. It's the second part, it's the 2x to the negative 2.
Oh.
That part is,
The whole thing was.
no, the first part.
Okay, Olivia.
8x.
I don't know it, man. I just don't know.
Wait, you're the one.
Okay, and.
Miss, you have to answer.
I just know it's wrong.
Huh? Yes. Okay, the 8 cannot move up. No, I don't yet. No, I don't yet. But you can do it in your calculator. That is not right.
What I do?
Totally knew
I mean, we're about to do it right now. So
They
just
weren't
hang
too slow. They
on.
weren't too slow.
No. Okay, your rewrite is wrong. Okay,
1/16, right?
it should be 1/16. Okay,
That's what
focus.
Yeah, I know.
Okay, this is the correct rewrite. It should be 1/8
-3.
I can choose on the bottom, so it's.
x to the minus 3, and then the minus 2x minus 2 is fine. Okay, but remember that fraction, that number can't move up, only the x can. So I add 1, what's negative 3 plus 1? Okay, x to the negative 2, and then if I'm going to divide by 2, that's the same as timesing by a half. What is an 1/8 times a half? A 16th. Now notice that it's a minus 16th, because it's a minus 2, yeah? Okay, and then for my next one, I add 1 to negative 2. What do I get? X to the minus 1. Then I have to divide by negative 1 on the negative 2. It turns to a what? Plus 2, right? Because it was already minus, and I divided by a minus. What else should you see? Yep. You like that? Okay, now I'm going to rewrite it like this. Okay, negative 1 over 16x squared. 2 over x plus c. Now, the first one of those is fine, but if it was multiple choice, this is more than likely the answer that you would be looking to pick. Okay? Number 3, do you remember what to do?
You separate them.
You separate, split them up. Very good. So I would rewrite this as x to the 4 over x plus 1 over x. Now, those aren't both going to reduce, but the first one can. What's x to the 4 divided by x?
X to the 3.
Hey, look at Marcel, front row.
Let's go.
Okay, what is the antiderivative of x to the 3? Ooh, x to the 4, what should be in the front, a third or a fourth?
A third.
It's the new exponent. So you add 1, get the 4, then divide by 4. And that is an ln. Now, on y'all's quiz, okay, a lot of y'all forgot the bars. I did not take off points, but I will on your test.
Does it matter when you put the bars? When you put the left one, if you put it before the ln, is that wrong?
That is wrong. It should be around the x specifically. Okay. Go down to number 4. Did you learn a product rule? No. What should you do?
Distribute.
Distribute. Good. I'm not going to do that one. You can figure it out probably. What about number 7? Did you learn a product rule? No. So what you need to do here is rewrite,
As a fraction.
and it's y to the 3 times y to the 1/2. Now you learned in Algebra 1 what to do with exponents when you multiply the bases. What do you do with the exponents? You need to add them. Okay, so I'm going to put right here, you need to add exponents to combine. So what is 1 plus, or I'm sorry, what is 3 plus a half? It'd be 3.5, but let's turn that into a fraction. What would it be? Y to the 7/2. Now, quick question. Could you put 3.5? Someone asked me that last period. Yeah. Now, if it's multiple choice and it's a fraction, you might be screwed. Okay, but you could do that if you want to.
It does
Okay?
look like it.
That would be fine. Okay, so I add 3, which is 6/2, plus 1/2 is 7/2. Okay, now do your rule. Add 1, then divide.
What's the
2 over 2, yep. So what is 7 over 2 plus 2 over 2? 9 over 2 is right. So I add 2 over 2, I get 9 over 2. And then how do I divide by 9 over 2? A plus C. Oh yeah. I better see it on there or else you're gonna see a point deduction.
From council about we're all in this together and High School Musical jokes. I don't even give a shit about. Let's see all of this.
You're gonna remember it though when you take your test.
What about number 2?
Oh, he's
Okay.
the worst.
I feel like I'm tripping.
He's an actual dad.
so
They're both
corny.
actual dads.
Okay, yes. Now listen, number 2, you really need to cube both of the pieces first. So can I write it as this 2x to the minus 3? Can I do that? No, you can't do that. How many things are cubed?
So many things are cute.
Okay, this is really 1 over 8x to the 3. I would cube it while it's on the bottom. 2 cubed is really an 8, and the 8's got to stay, the x gets to move up. So this would end up being 1 over 8x to the minus 3, and that should look familiar because you just did it. Okay, it was this guy right here. What did that term come out to be?
-2.
What?
-1, 16.
I said x to the negative. I'm an x to the -2.
Yep, you're close. There is a -2. Okay. What about number 12? Okay, go down to number 12. What's the antiderivative of 1? What's the antiderivative of secant squared? Plus or minus tangent?
I just saw the -2, so I'm just like -2.
Okay,
You don't have to listen.
do it. Okay, I'm going to do one more off the front and then I'll give you time to work. What about 13?
Yeah, that was the one I had trouble on when I looked through it.
Okay. Is there a product rule? No. What do you have to do? Distribute. Okay, so when I multiply that in, this is really the integral of secant theta, the secant theta tan theta, plus, and then if it's secant times secant, how would I write that? Okay, now I do want you to adjust something on here. What should the dy be at the end? D theta. Okay, so fix that. Okay, so if you do not have your pink sheet, I don't know, I guess I lost mine. I didn't lose it, I showed. Oh, here it is. Okay, what is the integral of secant tan? Ready? It's underlined already. Secant tan, what's the integral? Secant, what's the integral of secant squared? Tan, they're all on this sheet that you get to use, okay? So if I'm doing the first one, integral of secant tan is secant theta. And then the integral of secant squared is tan theta. Is that good? Oh, I was going to say, do you see a mistake on my paper?
No.
She does it again.
Okay. Good? Okay, turn the page. Let's do 1 or 2 off the back, and then I'll just let you work. Okay? Yeah, you know, Sean, most people do their homework, like, on their own when they get home. No, it's not your thing, but... got it. Cross out number 18. You don't have to do that because it's just like number 23.
Okay.
Okay, pick 2. 24. Okay. 21. Okay. Okay, I kind of want to do a normal one, so let's also do 19. Okay, now if you're not good at trig, eventually you got to figure something out. So you can memorize the unit circle, okay, or do hand trig, doesn't matter to me. Number 19, what is the antiderivative of cosine x? Okay, snow cone, snow cone. If I'm at cosine and I go up, where am I at? Positive sign. Remember that for derivatives, you go down. Okay, but for antiderivatives, you go up. Then remember, if you have endpoints, there's no plus c, you're plugging in the y values on the endpoints. So I'm going to plug in pi fourths, then I'm going to plug in 0. Okay, pi fourths, if you do hand trig, is your middle finger. Signs on bottom. How many fingers on bottom? Root 2 over 2. Okay, next I'm doing 0. 0 is my pinky. No pinky fingers below that, so it would be 0. Then what do I do with those two guys? Subtract. Yes? You have a question? No. So root 2 over 2 minus 0. Now, obviously, could you just put root 2 over 2? Sure. Okay, go to number 21. What's the antiderivative of secant squared? Tan theta. And then what are you going to do with the endpoints? Plug them in. Pi fourths, and then we want the tan of 0. Now, remember that when I want tangent, that's really sine over cosine of pi fourths. And what do you notice for pi fourths about sine and cosine? Look at your fingers. You have 2 on top and 2 on bottom. That means that they're both what? Root 2 over 2 divided by root 2 over 2. What do you get when you divide the same thing with itself? 1. Okay, so this is 1. Okay, now let's do 0. I need the sine of 0 over the cosine of 0. Okay, this is your 0 finger. No fingers on bottom. What's sine? 0, but all my fingers are on top. What's cosine? So 0 divided by 1 is 0. And then what do I do with my endpoints? Subtract. 1 minus 0 is 1. Okay, last one that I'm going to do with you, 24. Okay, you have to graph it. Do you want me to graph it for you? You can do it. Which way does minus 6 shift the graph?
To the right.
Okay, so 1, 2, 3, 4, 5, 6. Then draw your V. Okay, and then I want to shade from 0 until 8, so 7, 8. And I'm going to shade my graph from here to here. How many shapes am I going to make? 2. Now, if I want to know how tall these triangles are, all I have to do is plug in the x value that they're at to know how tall they are. So let's say that I want to plug in 0. Okay, what is 0 minus 6 plugged in here? 0 minus 6. What does that give me? Negative 6, then absolute value is, so this is 0 comma 6. Okay, and then what about this one over here? I'm plugging in 8. So if I plug in 8, what's 8 minus 6? 2, and then absolute value of 2 is 2. So this side is 6 tall, this side is 2 tall, and then you'll need to find your bases as well. So this first one will be 1/2. How long is my base from here to here? 6. How tall is it? So 6 times 6 is 36. Cut it in half. That one's 18 plus. And then for my second one, it's 1/2 base times height. My base is 2. My height is also 2. So 2 times 2. Half of 2 times 2 is half of 4, which is 2. Total area is 20. Okay? And actually, this reminds me of something, Sean.
What?
I have to tell you something.
Oh, yeah.
I realized this after y'all already left one day. I know y'all already turned in this homework, but that one, you remember that absolute value one that we ended up flipping at the end? That was wrong. Okay, I want to show you why just real quick. What homework was it on? Do y'all remember? Was it homework 4? 6?
It's not 6.
It was 6?
No, I don't think it is. I don't even remember how.
Yeah, it was 6. Okay, just look. You don't have to write it down on yours. Okay. Look real quick. Okay, which way is this gonna go? So factor in here. Okay, I would go 4 is my y-intercept. Okay, which is here. Negative 2 is your slope, so you'd go down 2 over 1, down 2 over 1. Then when you hit the x-axis, you bounce up. Okay, and the problem was, okay, that Sean had said, wait, it's a negative 2x, so the v opens down. Okay, and I was like, oh yeah, you're right. Okay, that's wrong. It would open down if it was like this. Where is the negative on this one?
No, I was saying it would open the up, like it should open, or it should be flipped or something.
But it shouldn't be because the negative is inside. Okay, so what you would, so if you graph it in your calculator, it is like this. So what you should do is for any, I'm sorry?
What's the negative do then?
The negative makes my original line go down and then bounce up. Yeah?
So what would happen if it was a plus?
If it was a plus in here, it would shift it to the left. It would shift your V backwards. Okay? So if it's a negative in the front, then your V is going to open down. Okay, but the good news about this is that they don't test absolute values that much. You should kind of know how to graph them. Okay, but for that one, just know it should have been here and then 0 to 5 and then same thing. Okay? All right, you have the last little bit of time to work. Make sure if you have questions, know which ones you need help on tomorrow so that I can help you. Okay? Yeah, sure.
Oh yeah.
Top or bottom, Jessica?
Yeah, for sure.
Top? Marcel, this seed is going to be good for you.
Is
Really?
it though?
I think so.
it is. I think
I think it is.
I'm learning a lot more.
Negative.
Now, Yoel, I don't know about his seed choice. Seems like a bad idea.
We're getting there.
Hopefully by